Most sports cars operate within well-understood physical boundaries, but at 420 kilometers an hour, those basic rules of automotive design break down. The physical forces involved do not scale linearly with speed, they scale exponentially. When the 1500 horsepower W16 was first proposed, the industry was skeptical. The consensus held that such a dense concentration of power would generate enough heat to melt internal components and produce torque levels capable of compromising the chassis. This graph illustrates the problem. As the vehicle's speed crosses 400 kilometers an hour, the air rushing over the body creates lift, attempting to pull the 2-ton vehicle off the ground like an airplane taking flight. To prevent the tires from disintegrating under this rotational force, the engineers at Molsheim had to abandon standard manufacturing. They adopted solutions from aerospace engineering and Formula One. Beneath the leather and polished metal, the Chiron is a calculated engineering solution to the extreme constraints of automotive physics. The center of the vehicle is occupied by a W16 engine. Hand-built from 3,700 individual parts, it utilizes 4 turbochargers designed to engage sequentially to eliminate acceleration delay. This schematic of the W configuration shows how the engine manages that airflow. The first pair of turbos spools up immediately, while the second pair engages at 2,800 RPM to maintain a linear output of 1,500 horsepower. This power generation creates a dangerous level of heat. During peak operation, exhaust temperatures reach 500 degrees Celsius, while the kinetic energy of braking pushes the discs to 1,100 degrees, the temperature of glowing lava. To manage this thermal load, Bugatti installed ductile titanium mufflers and a cooling network that circulates 40 liters of water through the powertrain 20 times every minute. To prevent the brakes from failing under 1,100-degree heat, Bugatti developed the world's largest 3D-printed titanium calipers, engineered to handle the thermal stress without warping. The engine's output is only sustainable if this thermal energy is perfectly managed and expelled. Beyond heat management, the car must survive its own torque. At 420 kilometers an hour, the vibrations and rotational forces are intense enough to shear standard metal chassis components. The Chiron is constructed in 2 distinct sections. The front is a hollow carbon fiber monocoque containing 2.5 kilometers of wiring, all fastened with titanium screws to minimize weight. During the assembly, or marriage, the front cockpit and the 750-kilogram rear engine section are joined together by exactly 14 titanium bolts. This 2-part structure is a safety requirement. In a high-speed crash, those 14 bolts are designed to shear, allowing the engine block to break away and isolate the driver from the impact energy and fire. Even with a reinforced skeleton, the car must fight the atmosphere. At high velocity, the air moving over the body naturally generates lift, turning the chassis into an aerodynamic wing. Bugatti's form follows performance philosophy addressed this through the C-line. This design traps impacting air pressure along the flanks and forces it directly into the engine and brake ducts for cooling. Stability is maintained by an active aerodynamic system centered on a 1.5-meter rear spoiler that adjusts to the vehicle's speed and position. 0.8 seconds after the driver applies the brakes, the spoiler tilts to a 49-degree angle to act as an air brake. This maneuver generates 850 kilograms of downward pressure on the rear axle, allowing the 2-ton vehicle to come to a complete stop from 400 kilometers an hour in 9.3 seconds. The Chiron weaponizes the atmosphere, using impacting air pressure to maintain the mechanical grip needed to stay on the asphalt. To test these engineering solutions, Bugatti attempted to break the 300-mile-per-hour barrier on a test track in Germany. The test was conducted by driver Andy Wallace, who had to manage the physical stress of the machine at its absolute limit. At 136 meters per second, human senses struggle to keep pace with the incoming visual data, making it difficult to maintain control of the vehicle. The custom tires were rotating 4,100 times per minute, with 7 metric tons of centrifugal force pulling at the rubber. Wallace maintained full throttle until the Bugatti reached 304.77 miles per hour, shattering the 300-mile-per-hour barrier. The Chiron is proof that there are no miracles in technology, only an obsessive dedication to problem solving. It embodies the brand's original philosophy. If it's comparable, it's no longer Bugatti.